Hey everyone, and welcome back to The Explainer. So let's just jump right into it, because today we are unpacking one of the most universal and honestly kind of bizarre mysteries of human existence. We're going to map out the exact architecture of why you, yes you, have completely and utterly forgotten the first 3 years of your life. I mean, really think about this for a second. You lived an entire, incredibly rich life before the age of 3. You opened your eyes for the first time, you heard your mother's voice, you tasted real food, took those wobbly first steps, and spoke your very first word. And yet, you remember absolutely none of it. Not one single fleeting moment. So why can't you remember being a baby? Now, most people, and maybe you're in this boat too, assume the answer is pretty simple. You figure your infant brain just wasn't ready yet, right? That it was just too weak to press the record button. But here's the really fascinating twist. That assumption is entirely wrong. Your baby brain was literally recording everything. Way back in 1905, Sigmund Freud was actually the first person to put a name to this whole thing. He called it infantile amnesia. It basically describes our inability as adults to retrieve episodic memories from before we were about 2 to 4 years old. But, just defining it didn't really solve the mystery. It just laid the groundwork for this massive scientific puzzle that took over a century to unravel. Because to actually solve this, scientists first had to prove that babies do, in fact, form memories. And that brings us to the 1980s. A psychologist named Carolyn Rovi Collier at Rutgers University ran this absolutely brilliant experiment that completely shatters the weak brain myth. She took a ribbon, tied one end to a baby's ankle and the other to a mobile hanging right over their crib. Naturally, the babies quickly figured out that kicking made the mobile move, and they absolutely loved it. But here is the kicker, pun intended. When she brought those same babies back days later, they remembered. They started kicking immediately. The absolutely crucial takeaway here is this. Infant brains can learn, they can store information, and they can recall it. 2-month-olds held onto that memory for days. 6-month-olds, they remembered the kicking trick for weeks. So the memories were, without a doubt, being recorded. But by the time we reach adulthood, every single trace is just inexplicably gone. So the real question we need to be asking isn't why babies can't form memories, it's what physically destroyed those recorded memories over time. All right, let's look at the first layer of this mystery, the hardware problem, or as I like to think of it, a bridge not yet built. To figure out what happened to all those lost memories, we really have to look at the physical structure of the developing brain. Think of the hippocampus. That's a small, curved structure deep inside your brain as the ultimate engine of memory. It takes a lived experience, maybe a weird dream or just a walk in the rain, and it encodes it into a little mental movie that you can replay in your head years later. Now, in an adult brain, the hippocampus teams up with the prefrontal cortex to tag and safely store those episodes. But in infants, the connections between those two areas are severely underdeveloped. There's this key region called the dentate gyrus. It basically acts as the gateway for new memories, and it just isn't fully wired up until you're somewhere between 2 and 4 years old. So your infant brain was totally capable of filming these short-term mental movies, but the physical bridge simply wasn't built yet to transport them over into long-term storage. Which leads us to layer 2, the biological cost of growth. Because honestly, the bridge not being built is only half the story. The memories you did manage to hold on to faced a much, much more aggressive threat. And it all comes down to neurogenesis. That's the extraordinary rapid-fire production of new neurons during the first few years of life. Now, these new brain cells are absolutely essential, right? They're wiring up the circuits you're going to use for the rest of your life. But a couple of neuroscientists in Toronto, Sheena Jocelyn and Paul Franklin, had a hunch that this explosive growth actually came with a massive cost. Imagine your brain as a house. To make room for a bigger, smarter adult brain, it has to constantly build new rooms. But in doing so, it physically has to tear down the old walls. Every single time a new neuron integrates into an existing circuit, it disrupts the connections that were already sitting there. And those were the very connections holding on to your early memories. And to prove this, they ran tests on mice. When they artificially ramped up neurogenesis in adult mice, those adult mice actually started forgetting things they had previously learned. There was no way around it. And the reverse was true too. When they slowed down neurogenesis in infant mice, those infants held onto their memories way longer than normal. So your baby brain wasn't too weak at all. It was just too busy growing. It was literally overwriting itself. Okay, moving on to layer 3, the missing main character. So we've got a hardware issue, and we've got a biological overwrite. But there is a third, deeply psychological layer to this whole phenomenon. Back in the late 1990s, developmental psychologists Mark Howe and Mary Courage introduced this totally profound idea. They argued that to form what we call an autobiographical memory, a memory where you can close your eyes and replay an experience, you need something that we all just completely take for granted. You need a you. You need a continuous sense of self to act as the main character of that mental movie. And we can actually pinpoint exactly when this you appears using something called the classic rouge mirror test. If you take a baby, put a little dot of rouge on their nose, and put them in front of a mirror before they're 18 months old, they treat the reflection like it's just another child. They literally don't know it's them. But right around that 18-month mark, boom, there is this sudden, distinct birth of self-recognition. They look in the mirror, recognize the reflection, and reach for the dot on their own face. Which brings us to a pretty mind-bending realization. Before that moment of self-recognition, there simply was no narrator inside your head. Without an understanding that you exist as your own separate person, there was zero framework to attach an experience to. You can't remember being a baby, in large part because the you experiencing it didn't even exist yet.
And finally, layer 4, the language scaffolding.
All right, we're almost at the end of this mystery, but we have one final cultural layer to uncover. Just like a writer using a pen to give shape to thoughts on a piece of paper, developmental psychologist Catherine Nelson found that language doesn't just describe our memories, it quite literally structures them. Before you could speak, your experiences were just these raw, unfiltered sensory impressions, just flashes of light, bursts of sound, raw emotion. But without words, those impressions had nothing to hang on to. Language is what gives memory a skeleton to survive on. Nelson has this quote that perfectly encapsulates the idea. Experiences without language are like water with no container. They exist beautifully for a moment, and then they just spill out and are gone forever. It's only when children actually start speaking, and specifically having back and forth conversations with adults, like, hey, do you remember when we went to the park today? That their ability to form permanent lasting memories just completely skyrockets. And you know what's crazy? This brilliantly translates into real-world data across the globe. Psychologist Chai Wang at Cornell proved that the actual culture you grow up in literally dictates how far back in time your memory reaches. For instance, the Maori of New Zealand have a very heavy oral tradition that emphasizes personal history, and their first memories reach back to around 2.5 years old. Western cultures, where parents frequently narrate and ask kids questions, usually hit around 3.5. Meanwhile, East Asian cultures, which historically put less focus on the individual narrative, often don't see first memories pop up until age 4 or even later. The culture you are raised in quite literally structures your brain's timeline. So, pulling this all together, we can really see the complete architecture of this thing. Infantile amnesia is not just one single failing of a weak brain. Your hardware connections weren't fully built yet. Your biology, that rapid neurogenesis, was aggressively tearing through your existing circuits to upgrade the whole system. Your psychology lacked a solid concept of self to anchor the story. And culturally, you had no language to contain the experience. It was, quite literally, everything all at once. Every single person you have ever met has a black hole where the first few years of their life should be. But it wasn't a mistake. Your brain was doing something far, far more important than just remembering. It was becoming you, and that required, quite literally, destroying the neural footprint of the person who came before. Forgetting wasn't a glitch, it was the necessary sacrifice for you to grow. Which leaves us with one final, maybe slightly uncomfortable, but totally fascinating thought to end on today. If you had no continuous sense of self, and the brain that held all your earliest experiences physically rewired itself beyond recognition, tearing down walls and completely overriding its own circuits, is the baby in your old photos actually you? Or is it someone else entirely who simply donated their body so that you could exist? Let that sink in. Thanks so much for joining me on this explainer, Focus Learners. Keep asking questions.